To evaluate a limit at infinity, we can't rely strictly on direct substitution. We can't rely on any of the strategies we studied in the previous section. There's one specific method for dealing with a limit at infinity. So with the first example, we have the limit as x approaches infinity of 6x minus 5 over 2x plus 3. What we need to do to evaluate this limit is divide every term, there's 4 of them in this case, by the highest exponent of x that is in the expression. In this one, that's simply x, so we take every single term and we divide it by x. We then we simplify, we reduce whatever we can. And then we look at what we have left over. I have 2 terms that still have x in it. Now if I think in terms of direct substitution, if I plug in infinity for x, I get 5 divided by infinity. Well, as you start dividing 5 by larger and larger numbers, the answer gets smaller and smaller until eventually it approaches 0. Now, that works slightly, but infinity isn't a real number, so we can't actually substitute it in. So we just have to think through that process each time. So what we're going to be left with is just the 6 over 2, which we can then reduce to 3. With example 2, now our largest exponent of x is x squared. So we're going to take every term, all 5 of them, and divide by x squared. Once we get that done, we'll reduce what we can. 2x squared divided by x squared is 2. We can simplify 5x over x squared to 5 over x. Nothing we can do with 2 over x squared. And we get 1 minus 9 over x on the bottom. Again, like with the last example, we have 3 terms that have x's left in them. Those will reduce down to zeros. So what we have is 2 over 1, which is going to reduce to 2. Example 3 is a little bit different. Now we don't have 2 equal powers of x, but our largest exponent is b cubed. So we'll take every term in this expression, divide it by b cubed, simplify what we can. We get 3 over b on top, and 1 minus 4 over b squared on the bottom. Any terms that still have a b associated are going to go to 0, but this time we don't have numbers on both the top and the bottom, so we'll have 0 over 1. 0 from the top, 1 minus 0 on the bottom is going to reduce to 0. Last example. Again, largest exponent is x cubed. So we're going to take all of those terms, divide them all by x cubed. We'll reduce what we can. And we'll take and we'll reduce to 0. So we end up with 4 over 0. 4 over 0 is undefined. Perfectly acceptable answer.